Our first problem asks us to find what the limit of f of x is as the limit approaches 2. So we're going to go to our graph for f of x, and we're going to find where x equals 2, which is right over here. And in these graphs, the limit is shown by the lines that are represented, and as we can see, there's only one line that meets x equals 2. And we can see that it meets x equals 2 at y equals 3. So you would write that down as the limit of f of x as it approaches 2 equals 3. Our next problem asks us to find the limit of f of x as the limit approaches 9. We go back up to our graph, and we find where 9 is. It's going to be right over here. And we can see that we have two limits approaching it, one from the left and one from the right. Now our limit from the left never actually directly touches it, and it goes down to negative infinity. And our limit from the right never directly touches it and goes down upwards to positive infinity. So we would write this down as the limit of f of x as the limit approaches 9 from the left is negative infinity, and our limit for f of x as the limit approaches 9 from the right is positive infinity. Now these two are completely different answers. Therefore, we would write this down as an overall, the limit of f of x as it approaches 9 does not exist because they're different answers. Our next problem asks us to find the limit of f of x as the limit approaches 5. We're going to go back up to our graph, and we're going to find where 5 is, which is going to be right over here. Now we can see we have two limits again approaching it, one from the left and one from the right. Our limit from the left meets x equals 5 at y equals 3, and our limit from the right meets x equals 5 at y equals negative 0.25. We're going to go back down here, and we're going to write it. The limit of f of x as the limit approaches 5 from the left is going to be 3. And our limit for f of x as the limit approaches 5 from the right is going to be negative 0.25. Now these again are completely different answers, so we would put the limit of f of x as it approaches 5 is equal to it doesn't exist. Our next problem is finding the limit of g of x as it approaches negative 10. This time we're going to go to this graph, and we're going to find where negative 10 is, which is going to be right over here. We can see that there is no limit coming over here from the left, so we would say that limit doesn't exist, but we do have one coming from the right. So we would say that this one meets it at y equals negative 5. And we would write it down as the limit of g of x as the limit approaches negative 10 from the left does not exist, and the limit of g of x as the limit approaches negative 10 from the right is negative 5. Once again, these are completely different answers, and one of them simply does not exist, so we would say that the limit for g of x as the limit approaches negative 10, would be that it does not exist. The next problem asks us to find the limit for g of x as it approaches negative 6. We're going to go back up to our graph here. We're going to find negative 6, which is going to be right over here. And we can see that there's two limits, one coming from the left where it meets negative 6 at y equals 3, and our limit from the right also happens to meet it at y equals 3. Therefore, we would say our limit for g of x as it approaches negative 6 from the left equals 3. Our limit for g of x as the limit approaches negative 6 from the right is 3. And because these two are the same answer, we go ahead and just say the limit of g of x as the limit approaches negative 6 equals 3. Our next problem asks us to find the limit of f of x as the limit approaches 10 from the left. So we're going to go back up to our f of x graph, and we're going to find 10. As we can see, we're only going to care about the left side, and we only have one limit approaching it from the left side. And it happens to meet x equals 10 at y equals 1. So we put that down as a limit of f of x as it approaches 10 from the left is going to be 1. Our next problem asks us to find the limit of g of x as it approaches 0. We're going to go to our g of x graph and find where 0 is. Now we see we have two limits again, one from the left and one from the right, and they both happen to meet x equals 0 at -4. So we would put that down as the limit of g of x as x approaches 0 from the left equals -4. The limit of g of x as a limit approaches 0 from the right is -4. So overall, the limit of g of x as it approaches 0 equals -4. Our next question asks us to find the limit of f of x plus g of x as they both approach -2 from the left. So we're going to go to both graphs and find -2. We're going to start at the f of x. We have -2 here, and we're only going to care about the left side, which is going to be this side, and we can see that it meets it at -2. Y equals -2. We're going to write that down. As it approaches -2 from the left, for the f of x is going to be -2 plus, we're going to go back to our graph of g of x, and we're going to find -2, which is going to be right over here. We only care about the left side, so we're going to look at this one, and we can see it meets at y equals 3. So we're going to go down here and add 3 to where the g of x would be. -2 plus 3 equals 1. So we would say that our limit as it approaches -2 from the left for f of x plus g of x would equal 1. Our next one asks the same thing, but it asks us to look at only the right side. So we're going to go back to our graphs, and we're going to look at the same spot, but we're only going to care about the right side, which is going to be this one right over here. All right, so it says it meets at y equals 3 for the f of x. We're going to write that down. And then we're going to go back up to our graph of g of x. We're only going to care about the right side, and our right side says it meets at y equals -2. And 3 plus -2 equals 1. So you'd write it down like this. Equals 1. Okay. Our next one asks us to find what the overall is for f of x plus g of x as the limit approaches -2. Now we already have what it is when it approaches the left and what it is when it approaches the right, and they happen to be the same answer. So we could simply put down the limit as it approaches -2 for f of x plus g of x is going to be 1. Our next problem asks us to find the limit of 2x plus f of x times g of x as it approaches -8. The first thing we're going to want to do is substitute -8 into the x's. And we're going to look at the graph to find where the y-intercept is for the x equals -8. We're going to go to our f. We're going to find -8, which is going to be right over here. and it happens that both limits meet at the same spot, which is y equals 4. So we would substitute that in. So it's going to be negative 16 plus 4. So we're going to go to our graph for g. We're going to find our negative 8, which is going to be right over here. And our limits happen to meet it at the same spot, which is y equals negative 1. We're going to plug that in. Right there. And then we would multiply this, and this would be negative 4. We add / subtract these, and we would get negative 20. So the limit, as it approaches negative 8, for 2x plus f of x times g of x equals negative 20. Our next question asks us to find the limit of g considering f of x as the limit approaches negative 6. Once again, we're going to want to put negative 6 into the place of x. For g considering f of x as a limit approaches negative 6. We're going to put f of negative 6. We're going to go to our graph for f of x and find where negative 6 is, which is right over here. We can see both limits happen to meet it at the same spot, which is y equals negative 4. We're going to go ahead and replace this for the limit of g at negative 4 as the limit approaches negative 6. And now we need to find negative 4 on g of x. We're going to find x equals negative 4 right here, and we're going to see that both limits happen to meet at the same spot right here, which is y equals 5. We're going to go back down here, and we're going to say that the limit of g considering f of x as the limit approaches negative 6 equals 5. Our bonus question asks us to find the limit of g considering g of x as the limit approaches 4. First thing we're going to do, we're going to substitute 4 for the x. Limit of g as the limit approaches 4. We're going to go to our graph, and we're going to find our x equals 4 right over here. We can see both limits happen to meet at the same spot at y equals 0. So we would replace that. Say the limit for g of 0 as the limit approaches 4. And then we have to find 0 on g of x. It's going to be right here. And we can see both limits meet at the same spot at y equals negative 4. So we would write that down as the limit of g considering g of x as the limit approaches 4 equals negative 4.